Hello, good afternoon. Hi, everyone. We are two people on stage. Today, we are going to show what we did as a project in Telenor. And I was not doing everything myself. Actually, it was a teamwork. That's why I wanted Milos on stage. And that's why today you're seeing two people on stage. We are from Telenor. I noticed during this conference that there are not many, actually among top 10 or top 50 companies in Serbia, operating in Serbia, they're not presenting almost anything here on this conference. I'm glad you're here, and I'm glad that we can show that the data science can be done also in big companies, and that innovation is also possible within big companies. Raise your hand if you ever dreamed to become a data scientist when you were a kid. No one. Exactly. And that's why this conference, and that's why you're here today. This is a profession, an occupation that was impossible to even think of 5 years or 10 years ago. And most likely that majority of you sitting here in this hall will have occupation that is unknown today. Thanks to data science and thanks to artificial intelligence. And it's not an easy task. We are from Telenor, it's a big company. It's not an easy task to say, hey, data science is necessary, data science is must, so let's do it. Let's implement data science in companies. You need to prove that it works. You need to prove that you're not going to harm. You need to prove that you're going to bring better customer satisfaction, and you need to prove that you're going to earn more money. It's not easy, so it's a constant battle. I'm saying actually from many of you who would like to implement data science and who believe that that's a simple task. Not yet. There are still some years to go, but this conference is actually showing a huge interest and that we can do it together. Okay, let's move further. Let's show actually what we are going to talk today. 3 things we are going to show you today. First is applied data science project. In marketing. Marketing is one of the good places to show how data science is needed, because you can generate better customer satisfaction and you can earn more money. So we are showing example of applied data science in marketing. Second, we are going to talk about that we applied this in B2B market. So it's business to business, and I'll actually show a couple of slides for those of you to just shine some more light on specifics of B2B. And what we did is actually using open source software available. We did everything in R. To our knowledge, this is actually, we are the only one who offered for B2B customers something in the telecom industry, and we believe that we are the first in CE region. If there are some more of telecom companies, hey, thanks, welcome in the club. But this is really exciting, and it works. If you are a Telenor client, business client, then probably on your mobile app you will have an option saying Telenor vam preporučuje, which means that you can actually choose something that suits your need. We implement data science to track your needs and to offer you what you really need. It's easy then to activate because it's on your mobile phone, it's an app. B2B. What is business to business? There are some key specific things on operating B2B environment. So it's a company. So you have a lot of employees, but there is also management. And then level of decision making is different. Then also you have inner group of So beneficial in a group, you treat them differently. In telecom industry, for big companies, we are still offering tailored-made offer, and a lot of them are still paying based on traffic, and that's what is called pay-as-you-go, which is not common, and you are not seeing that with the regular consumer market. All our offers for B2B are industry specific, also geography specifics, and then there are also some inactive users, so a lot of specific things for B2B. Why data science for B2B on mobile apps? Because soon Generation Z will be your customer. They are educated, they're being educated on your mobile phone. 70% of young population, they want to build their own companies. Okay, so they're knocking on your door. You better start thinking now, you better start creating offers via mobile phone, what they are used to. And of course, millennials are really multitasking among 5 screens, and that's what I notice for my kids. And then they say, okay, data science is really great to implement if you want to offer personalized things. Everyone has different needs, so offer him something different. Well, in B2B, that's a general thing. That's a bread and butter. You are always offering something different to different companies. So customization based on local offices, on industry, on seasonalities, that's a regular thing in business. So yes, it's a great place then to implement data science. Lack of speed. Why it's good then to offer these things on a mobile phone or an app? Because hey, I'm now in roaming. I don't have now time to call IT manager in my company, or I call Telenor representative to activate me certain things. I want it now, and then it's good to offer them now, which is then great customer service. Do we believe that suddenly tomorrow everything will move in B2B environment on a mobile phone? No. A lot of companies still will require human touch. Differentiation in the future will be on a human touch. So you need to make a right balance. This is to show you that we are not building completely different world and architecture in Telenor to create offers for B2B customers. We are reusing as much as possible hardware and architectures and the stuff that are already existing for regular consumer market, and then build a business B2B specific on top of that. And this is then what in this slide is shown. Okay, what is actually the offer that we offer to business customers? It's called next best offering. This is just a block diagram. A block diagram is saying that we are gathering and collecting the data on customer behavior. Then we do this data science here and engineering here. Then we send offer and communicate to client on the mobile phone. We select top 3 offers. Telenor is recommending you 3 offers, and then you can click and select. So, from the very beginning to the very end, this is what we implement in open source software. We implement all this in R. And this is then more detailed block diagram that we are actually gathering a lot of information, and then we process this information using a campaign management system to send the offers to different customers. So this is kind of a small block diagram, but also it's important to stress that for this we are using SQL. And how does it look like? This is then a real-life application. So we have a lot of data, we are processing this data, we know based on your behavior actually what the best need is, and then we are sending you that offer. this is how it looks like. This is a standard Buy Telenor app. This is a business user or Moja Firma, and then you have here 3 offers. You have some explanation of what this offer means, how much they cost, and then you choose some of these, say activate, and then you'll pay a certain amount of money. Are you sure? Yes, and then you get confirmation that you bought this offer. So it's very easy, and it's available immediately. If you don't have mobile app, then you have a regular USSD menu. Then there is an option 2. Telenor is recommending you, and then you have 3 options. If you choose any of the options, then you get the explanation of this offer. Yes, you want to buy it, and then you will get confirmation in the next 5 minutes. So it works, and this is actually why we're here today, to tell you that it's possible to implement data science in the real world, to implement even today in the application, and in the future, I believe it will be a must. We did it together. Milos is a lead data scientist in my team, and 80% of time he's busy with data preparation, pre-processing, processing, and 20% of time he's complaining on the need to do the preparation and processing and those kind of things. But Milos, please tell us actually some of the specific things and what we did, how we implemented actually data science to create these offers.
Okay. The battery is going to die, so can you please borrow me your mic?
Sure.
If you don't mind. Okay. So hi everyone. Honestly, I expected a lot of more people today, so I'm really sorry that we didn't come in a large number. So I'm here to tell you the story actually about the project we launched a month ago. It was a really tough job. It was really challenging to make this happen. So we made a project that we actually offer a lot of products. We have a lot of users, business users, and we want to offer them what they really need to activate and what they really need, what they want to activate in order to upsell existing database, to cross-sell existing database, and to gain more revenue and to acquire more users to use our app. So those are the main business challenges, and this is our main goal why we launched this project. So here you see actually the basic workflow of each data science project that we made in our team, especially for the MBO, Next Best Offer project. For every product we offer, we separately create, so this is the basic logic, we separately create actually a machine learning algorithm and pipeline, entire pipeline. So for each product we created this, what you see actually here. These are the main steps that are used. The first step is actually we call our database. We call for data. We actually extract a lot of data from our data warehouse. We know specific for each product to extract what data we actually want to use for our research and for targeting users. Then we do a lot of pre-processing. The pre-processing is, from my experience, the most important part, because you do a lot of research, you do a lot of plotting of the data, etc. And then after the pre-processing, you do, within that process, a lot of feature engineering. You create features, you create a lot of new, interesting variables. You might want to use them as an input to the machine learning model, and then you use all of those inputs as a good source for the machine learning algorithms, and then you train those algorithms on the train and test set, and then you get your targets and you send those offers through a campaign management system, through their mobile phones, and our users get their offers through their mobile phone, and we, through our follow-ups, we actually track all of those activations and how successful we actually are. So the next I will briefly or in depth describe all of those steps. First, I will try to explain how we actually extract data from our database, or I will try to explain you what kind of data we actually have. What are we tracking about our customers? What do we have? So firstly, we have two types of data. We track data about our companies, because we are doing business with our B2B clients. And then we actually use data such as segmentation information, contract info, and company info. And also we track data, more important data, about each employee of that company. And then what is the data we track? We track usage and behavior, revenue from those usage patterns. For example, usage, we track how many minutes the customer spend in national roaming traffic, how many megabytes of internet traffic he spent, and so on. And those are really important nature behavior we want to track for each product we offer. So it's different. For each product, it's a separate world, and we track all of those data and do separate research. And then, when we actually know which data we want to use, we automatically create queries using our language. This is a bit of technical information. We write all of our queries when we actually know what to write after the experiments. We write all of our queries in our programming language using drivers to our Oracle database. And then we actually execute all of those queries and get our data frames, get our data. We research the data in further processes, and then we store our data depending on the complexity of the query, because every big company has limitations of processing power. If some queries are really demanding, we actually store all of those results in a file system, and then in further research and improvements, we get those data from the file system. It's more accurate to get data from the file than from the analytics server, because it's more painful. So we store our data and update our data each month. We actually get data from our users monthly and daily, and also we are sending our offers and updating our offers monthly and daily as well. And then we use those queries and fetch our data in those time spans. So this is really essentially crucial and really important part. If you mess here up, you are messing the entire story that will continue. So this is really sensitive part. If you don't write query very well, believe me, entire team is going to fall down. From my personal experience, that's the truth. So the next thing is
it happens a lot for you.
What?
It happened a lot during this work. There were a lot of failures. A lot of time we got results that we didn't want, and then you do all over again till it's really working.
So it's a try and error. You need to be persistent. It's not a really easy job. You need to work really a lot to get to the end. So it's really challenging and really interesting. So that's the thing I love about my job. So the next thing is okay. You get data. You wrote your queries very well. So you want to examine your data. You have a lot of variables. You don't know what to do with them, and then you are trying to do something. What are you doing? You are plotting data. You are using different graphs. For example, we use R programming language and Python. We are starting to do with Python. So in R we use ggplot, for example, for plotting our raw data. For example, we want to see how users who activate some product behave, and comparing to users that do not activate a specific product. So we want to explore those differences between two types of people who use particular product and who do not use particular product. So that is the most interesting part. We examine raw data and we want to examine the nature of our data. And the next thing is, of course, we are running some statistical tests. For example, we are running correlation to see whether are some variables correlated to each other in order to maybe to merge all those variables using PCA or some other factorization or dimensionality reduction method. So these are, so I can say, descriptive statistics part. We want to feel our data, to know on a high level how our data behaves, how our customer base actually behaves. So when we do that, we proceed to this more advanced part. It's called feature engineering. This is the heart of our data science part. You actually do a lot of research here. You are making a lot of features. You are making a lot of experiments. You want to derive a lot of features. You are actually making a science of a data. You're actually using those data in order to create a new variable. For example, you use 5 different variables. You create a function from your mindset, from your creativity part. You're creating new variable that actually has a new meaning that can give you more information about the difference between users who actually buy and do not buy particular products. So you want to examine that difference. That is the most important part. And
you are actually putting here, you need 2 hats. In order to be a great data scientist, you really need 2 hats. And one is engineering hat, and the other one is business hat. In this process of doing feature engineering and extracting a feature and coming up with the new artificial features, you need a business hat. You need to understand what you're offering, what you're trying to do, and what are specific of the business you're in. And only when you understand that, that will make you a great data scientist, and the results and the features that you get, the features that you select are really meaningful. And this is then why Milos is trying to stress actually this part. This is incredibly important.
It's really important to know that other side, because if you do not know about the business, so you're just a programmer that writes the code and doing a request response. You're like a server, so that's not a data scientist, definitely. So after feature engineering part, you do within that process a lot of cleaning, selection, transformation, all of those typical data scientific parts. You're doing imputation of the data, you're cleaning a lot of data, and you want to see in a more clear manner how our data actually behaves. So it's the really important part to know how to clean your data and scale data, because some machine learning models are more sensitive to normalized and non-normalized data, but random forest ensemble methods and other methods are not sensitive, so you don't need to normalize and scale data, and that's a great thing. So the next thing is actually model design and optimization. Here is the artificial intelligence part. So in our team we use models from the library, from the R programming languages. We use pre-installed libraries, and firstly we pick up, for example, 5 or 6 models. In the most cases, we use ensemble methods, gradient boosting, random forest, ADA boost banking methods, and we use some neural networks and etc. And then what we do? We train those models using default parameters. Okay, I'll train 5 models on the one single problem, one product. I train those models, and what I see, for example, the model that fits the best for the problem. I see, for example, we observe the model that performs the best, and then we choose that model for further improvement. In the most cases, those are ensemble methods. Random forest, gradient boosting are the most efficient ones and effective. The most effective is actually gradient boosting, but it's the less efficient. It requires really the most processing power gradient boosting. So we are using mainly random forest for our problems. And then, after we choose our model, we actually do a lot of improvements. How we do that? We actually do fine-tuning of the models. For example, for random forest, we are changing number of trees, type of split. For example, we examine a lot of fine-tuning possibilities for our models, and then we choose. With all these possible combinations of configuration parameters, we actually choose the most optimal one that will behave the most optimal on the test set, on the unseen data, because we want to avoid that high bias, high variance trade-off underfitting, overfitting problem. So we want to find that sweet spot in between. In the middle, we want to where we want to actually our models behave the most efficient and effective to be optimal. So this is the challenge, finding that sweet spot between high variance and high bias with underfitted and overfitting models. So you actually really are into that to solve that machine learning trap. I would call it trap because it's a really tough challenge to find that sweet spot. So we actually do dedicate a lot of time in that part. So it's really cool stuff. You know, you have a lot of models. You play with those models. When you have clean data, feature engineered, doing all this stuff. So it's cool. And then I will address about evaluation metrics we use. For example, if you have balanced, unbalanced data, we also use a lot of precision recall when we have unbalanced data. So we plot our precision recall curves, and then we do a lot of, for example, if you have balanced data, we use receiving operating characteristic area under curve definition as our metric of success. So these are slightly the most typical and well-known metrics for evaluation. I have to say that the most creative part is actually how you extract data, how you use those models, and how you optimize those models. The metrics and the stuff like that are just here to help us to actually get this thing done in the most important, the most appropriate way. So,
and I would say this is also very important. So in advance, you need to set some expectations, to set some accuracy that you want to achieve, and then move it further. Because you need to put this in a production, you need to see how the clients will react. So don't try to go over and over and over in the years. You just try to actually iterate till you get a certain minimum criteria that you're happy with, move on, put it in the production, see what the results will be, and then come back to a model, implement those stuff, and then try to be more accurate.
Yes. So we have two parts where we put our models and everything in production, but we have our testing environment. I would call it a playground, where we play with our data, where we explore, experiment, and derive new conclusions. And then when we are sure about our assumptions, with our further tests, we actually put everything to production, and everything is going in live, and customers get our offers, and they are happy, we are happy, and we actually are measuring how much money we get and how much new users we have acquired, and upsell, cross-sell through our campaign. So it's a great challenge. The last thing is how we actually are doing to put all these things together. We have, for each product, we have separate machine learning pipeline you saw in the previous slide. So, for example, if you have more than 10 products, okay, we have more than 10 products, every model for each product gave us a target list for targeted customers, so we merge all of those target lists into single one, and then we search how our models have scored. For example, over 50% if our models have told us, okay, you should buy that product. We use over 50% threshold, for example. Sometimes even higher if you have a really big example of targeted users. We define threshold, we use those users, and then as a target list, and we put them in a target list, and we get select top three highest offers, and then we selected highest three offers from top three models. We get a target list and put everything through our digital channel. Through our mobile app, for example, we have a different channels. We have a mobile app. Users can get their offers from mobile app through a USSD. If they do not have a mobile app, we use different channels to target those users because we really want for them to activate those offers. And then when they activate that offer, we get, okay, it's a success, we measure that as a success, and when we run our follow-ups, we're measuring our success. We actually know how much users have activated, and we know where should we actually improve our models, create new ways of looking at the problem if we have missed something, because you are doing from the start, from the scratch, everything. We did this from scratch. We only have data warehouse, we didn't have anything. And we actually are really successful in this. This project is launched, it works really great, and users are getting those offers, and it's really cool and great thing to know that this actually works. So that's everything from me, and thank you very much.
Thank you very much. And this is just the beginning. This is just a first thing that in a B2B world that we did. That is, we are offering add-ons, national add-ons, roaming add-ons. We are going further to move on with machine learning within Telenor for B2B customers, for B2B clients. And it's not, as I said, an easy task to prove that data science is really a thing must have to implement, but it is simply a good place for innovation, and that we can try out these things, and here we are to show you that it works. Thank you.
You chose R for plotting and not Tableau, for example, because it takes less time?
Can you repeat the question?
Okay, yeah, sorry. So why did you choose R for plotting specifically?
R for plotting?
Yes.
Well, R is open source software. Maybe there are some other open source solutions, but R worked really fine for us. So it's
And it's indeed very fast. It's there, you just type in a command, you get what you want.
And what are the metrics you use for measuring the results? And how did you measure them in order to identify whether the offer was good or not?
Okay, I think we told that we use precision recall metrics. For example, if we want to know how much our customers have been successfully activated our product. For example, I think I didn't understand the question. Maybe successful metrics about our campaigns or about our machine learning models, how they actually predicted. Because if we actually measure success of our campaign, we want to know how much users from our target list have activated the specific product. So we measure. That's the simple metric. But if you want to measure specific how our machine learning model has performed, so we measure those F-score. We use those F-score metrics, precision recall metrics, ROC curve. We use that for testing performance of our models. So I hope I have answered the question. So if not, you can meet me outside, and I will answer.
And do you have any idea of what is the percentage of the customers that are actually getting the offer?
What percentage of customers get the offer? So the number of customers are exponentially growing of using the app. We are broadcasting our campaigns through different channels, through our app. We have a good activation rate through our app and through our other channels. So we expect that it will be much bigger in following quarters. So
it goes really side by side with the overall digitalization and moving the stuff online, more in digital world. So data science will grow in the same pace as your digital business is growing. Our digital business is growing. And then the more customers are using app, the more of these offers they will get. Actually, that will be a future because it's pretty simple, it's pretty easy, it's on a click. So I believe that is really the direction. It's, again, we are dealing in B2B world, so for business customers, so there will still be a lot of human touch. There will still be a lot of key account managers. Don't worry. For companies, you will have humans to talk to and to serve you. But we are going to balance. Maybe first start with very small customers, and then slowly try to serve also the bigger customers in this digital world.
Sounds reasonable. I'll take one more question. What is the amount of data that you were processing, and what is the hardware architecture you were using for training?
Well, we use amount of data is measured in gigabytes, more than 10-20 gigabytes, for example, on a daily, monthly basis. Business customers, it's the database of the business customers is a little bit smaller than consumer base, which is expected. So we have that opportunity to use that data to appreciate data. We don't have a lot of business customers as consumer customers, but we try to, from that smaller base, to actually gain the most and to offer as much as we can. And what hardware we use I don't know specifically the configuration, that's technical information, but we use data warehouse as our storing facility, and we use analytical server for our processing power, as our processing power environment for our experiments and stuff like that.
Okay, thank you. Thank you once again for your talks.
Thank
you
you
can
for
find
having
them
us.
in the breaks to talk to them more, because I still had some questions here, but we need to carry on. So, let's get one more round of applause.